Hello, I'm going to be talking about this paper, The Power of Scale for Parameter Efficient Prompt Tuning. This paper is related to a lot of other papers that we have been talking about in the discussion group and is really focused around moving beyond just this idea of prompting where you supply some tokens on your own to try and get the model to perform better on downstream tasks, but instead to actually tune the parameters of that prompt. So you're not coming up with some embedding yourself, you're letting the model train to develop an embedding. So this is what I refer to as like a non-NLP prompt. So what they're mainly showing here is that at scale, this method works out really well. They have this figure here, figure 1, which is sort of the meat of their paper, which is to say that this green line here, which is their method that they're coming up with, is going to perform just as well as doing something like model tuning or far better than prompt design. It should be noted that their model does not actually do as well as model tuning unless we're talking about extra large models, and they're specifically using T5, and I think it's like an XXL T5 or something that they show that this works out on. So just to get a little bit more into their methods, so they sort of fall between two different literatures. One, prompting, this idea I've already described, and adapters. Adapters are sort of extra parameters that you can put into a model, oftentimes to like force a model to condense some representation within the model. But in this case, they are just appending things to the input sequence to sort of have what, in my mind, is a little bit more of a natural representation of a prompt. Li and Liang, which I'll talk about a bit later, they are actually doing something similar, but instead of doing this just in the input sequence, they're doing this after every layer of the network. So, it's adding a little bit more parameters into the overall model. It sort of makes me think that they're just building a bigger model to a degree, whereas this paper is really, in a more exact way, building a prompt and are able to show relatively good results as it is. So yeah, as I was sort of alluding to, it adding just more parameters to this model, language model capacity is a key ingredient for approaches to exceed. So let's talk a little bit more about that prompt tuning becoming more competitive with scale. That again is going to be represented up here, and they are just unable to get to equivalent results with any smaller models. They do a number of ablation studies, so I will go ahead and just scroll all the way down to the ablations, and they are sort of consistently showing that this green bar, or this green line, is what their model is. This model is really only going to be performing well, or as well as standard models, if you are one, making sure that you're tuning along all of these parameters, but two, never as good as your model tuning unless you are looking at this very large parameter size. So some of the things that they're fiddling around with here are prompt length. So that makes sense. Like, how many extra tokens are there effectively, right, that you're building out? Two is prompt initialization. So you can imagine that you have random initializations for the parameters of that prompt, or you could initialize them to, as the green line is showing, is something that is like their best model, to initialize them to the actual class labels. They'll talk a little bit more about how that actually impacts things later on, which I think is interesting things. The pre-training method, so you can imagine span corruption being sort of that like random masking that can happen, and being able to then work around that. The Sentinel I won't get into. And then language model adaptation is, training it on a language modeling objective, which I think makes sense. And then the last bit is just the steps that are actually taking, like during the training of the model. So, I don't think any of these things are terribly surprising across the board. Sampled vocab and class labels do better for the prompt initialization. I think that more generally makes sense. Let me see if there's anything up here that is perhaps useful. they talk about some of the differences between their models and others, which I already touched on. Yeah, this is some more about their method, just so we're clear on the technical side of this. So they're going to have this conditional generation, where we're going to be predicting y based on p and x. And we can train that by maximizing the likelihood of y via backpropagation, only applying gradient updates to theta p. So what they're saying is they keep the rest of the model frozen, and they're only like tuning their prompt basically. And this is important because we're really not moving the whole model around, right? We're just training this prompt. They are going to concatenate that prompt to the embedding input, like I said, forming a single matrix as follows. So let's get back into some of the stuff after the ablation. So yeah, the comparison to similar approaches, it's a really, really great overview. I highly recommend reading this if you're want to learn more about prompting. Resilience to domain shift is sort of the next section here. So what they're saying is, okay, we're freezing the core of this model and we're really just tuning this prompt. That provides a lot of benefits because you're ideally, in a way, like keeping the main linguistic capacity of the model intact while only tuning something to do stuff for some downstream task, right? So they're going to specifically look at zero-shot domain transfer on 2 tasks, question answering and paraphrase detection. And what they're able to show is that prompt tuning outperforms model tuning on the majority of out-of-domain data sets. And this 12.5 F1 gap between the two approaches on textbook QA, I think is pretty darn good. So just looking at this here, the results are not quite as close for DORC and DROP. They hypothesize this is partially because textbook QA and BioA SQ are like more domain specific than some of these other tasks are. So there's almost like some more specific language to be used for textbook QA than like drop, for instance. And as such, it's easier to tune that without basically overfitting the model, because you're only tuning the prompt. Let's see that. Yeah, they say model tuning may be overparameterized and more prone to overfit the training task. So, next, prompt ensembling. This is where things get really cool because obviously prompt ensembling sounds really expensive, right? Well, because all we have trained is just this tiny little prompt on top of what is otherwise a static model. You can keep the model parameters static. I'm just scrolling up here to find this because they are sort of showing like how you can combine things together and not sort of get ridiculous amounts of like model parameters lying around, because we're not recreating like each of these task models such that these 11 billion parameters are separate from these 11 billion and so on and so forth. So just getting back to here, they're able to show that that is effective. Here's the graph that shows that their ensembling is effective. I don't think it's all that much more impressive over their average or best models. So I think that that is just okay, but the point is that it's super cheap, and that is good. So let me see if there's anything else here. Oh yeah, this interpretability section is also really great. I think it's very cool to give an idea of what prompting or prompt tuning is doing. So they find that for a given learn prompt token, the top 5 nearest neighbors of that token form tight semantic clusters. So you have like your vector representation of whatever it is that that token is, right? And they find that it is relatively similar to technology. They also find that random vectors drawn from the embedding space do not show this sort of semantic clustering. The thing that I think is also interesting here is when they do that class label initialization, those persist throughout training, which suggests that that is a good way to build prompts. The conclusion that I think they find, I don't know if this is true, would love to discuss this more, is that they are sort of saying that the prompt acts as a category determiner to give it some context for what it's supposed to do. So like when it's answering nature science categorical questions, the prompt can say, hey, this is scientific. think in this way. I don't know how true that is. They say there's more investigation needed there, but yeah, would love to hear people's thoughts. That is it for this paper.